In this unit, we're going to start to look at sequence. When you're thinking of sequences, think patterns. So let's just intro it today. Our first day is arithmetic sequences, and tomorrow we'll look at geometric sequences. So first of all, a sequence is an ordered list of numbers that usually form a pattern. So here we have 6, 11, 16, and 21. And our pattern is that it's increasing by 5 every time. Sequences can have a definite end, so we can have 6, 11, 16, and 21, and that's all there is to it. Or it can go forever, infinite, and we represent it by those dots. So if you don't have the dots, that means that there is an end to it. Each number in the sequence is called a term. The first term is denoted by T1, so we do it as a subscript, so be sure it's a little bit lower. And then we have term 2, etc. So in this sequence here, where we have -1, 1, 3, and 5, we can see that the pattern is that we're increasing by 2 all the way along. So the very first term is -1. You're stating what the number is in that position. Term 4 would be 5. If we wanted term 5, we have to add another 2 to it. So it would be 7 in the pattern. So just sort of think if you're continuing on. 7 and then 9. Term 6 is 9. Here we have another sequence, so another pattern that we need to figure out. And the sequence is 3, 12, 48, and 192. So our first term, what we're asking is what's in position 1? That's what that T1 means, and that's really important. Term 4, 1, 2, 3, 4. Term 4 is 192. So now in order to be able to figure out what term 5 is, we need to figure out what the pattern is. Maybe pause, think about it for a minute. What we have here is that every term is being multiplied by 4 in order to get the next term. 3 times 4 is 12. 12 times 4 is 48. 4 times 12 is 192. So term 5 is 192 times 4, which gives us 768. 768 times 4 gives us 3,072. So then pattern continues forever and ever. What if we wanted to find term 100 though? Do we really want to keep multiplying by 4 and writing it down 100 times? That's too much work. So luckily there are formulas. That's what this says here. Sequences can usually be represented by a formula called the general term, which is denoted by T at n. So that means that we can find any term number we want. Term 11, term 22, term 100 even. So here is a general term. That equation there is a general term. That means we can find any term number we want by substituting into n. So for example, if we wanted to find out what term 10 was, what the number is in the 10th position of the pattern, we would do 5 times 10 plus 3, which would equal 53. So if we had a pattern and we wanted to know what the 10th number was in that pattern, it would be equal to 53. Now we also have this formula here, same thing. If we wanted to know what the 10th term was in this pattern, which is different, we would have 2 to the power of 10. Remembering that it's important that you do your exponent first. So here we have 3 times 1,024 when multiplied together is 3,072. So the 10th term in this pattern would be 3,072. Now just sort of as an overview of where we're headed, the patterns where we were adding and subtracting here, these are arithmetic sequences, and that's what today we're going to focus on. Where the patterns here, where you had to multiply by 4, these are called geometric sequences, and that's what we're going to focus on tomorrow. Here is where you may need to do some pausing and maybe write some things down as you're working and listening. And it just can be really concise still in what you would need on a study sheet, not a full note. So now we're looking at arithmetic sequences, as I said. So these are addition and subtraction patterns here. So the actual definition is an arithmetic sequence has a common difference between successive terms. And that means just terms that are in order. So here, term 1 is number 1, term 2 is 8, term 3 is 15, and term 4 is 22. The common difference for this sequence is 7, and the best way to see it is take the term in front and subtract it by the term behind. So that equals 7. So checking the pattern, 15 minus 8, that's 7. So you can see the common difference between each term is 7. That's what we're adding by each time. This pattern and check our common differences as well, but we have to be a little bit careful because we're dealing with negatives. So my negative 7, subtract the term in front of it, which is negative 4. And when there's two negatives, we know it becomes addition. So my common, I just need to change that to a 4. I miswrote it. That becomes addition. So my common difference here is negative 3. Then I'm going to check another term, negative 4 subtract negative 1. That becomes addition as well. Got a 1, which is negative 3. So my common difference here is negative 3. And that makes sense because if you look, every time you go down the pattern, you're getting smaller. So it makes sense that there's a negative number there. Now let's look to see how this helps us with formulas that we can use for all patterns that are arithmetic. So let's determine the general term for the two sequences above. So the first one we're looking at is 1, 8, 15, and 22. So you can see here that term 1 is 1, term 2 is 8, 15, and 22. And now we're just looking to see if there's a pattern that helps us write a formula. So if we had 1 plus 0 times 7, that equals 1. So that's what our first term is. Then we have term 1 plus 1 times 7, which is equal to 8. Now these numbers here, just sort of see where they're coming from. The 7, hopefully you see it yourself, that's our common difference. And 0 is just 1 less than the term number. Look at, if we're talking about term 1, that's 0. We're talking about term 2, that's 1. Now let's keep going. To figure out where term 3 came from, we have 1 plus 2 times 7. The 2 is 1 less than our term number, and the 7 is our common difference. Now that makes us a term 3 of 15. The only number we haven't talked about is the 1. How did we come up with that 1 there? The 1 was our initial term of the pattern. There. So we have the initial is 1 plus 3, which is just 1 less than our term number, times 7. So that gives us term 4 of 22. So overall, let's look. If we're talking about a general term, for example, if we want to solve for term 100 and didn't want to write them all out, we could take our initial number of the pattern of the sequence and then add it to 1 less than the term number and the common difference. So we lay that out down here in our notes for you, and this is what, the key most important thing from today is that to find any term number in a pattern, you take a plus n minus 1 times d. D is the common difference, and a is your very first term. So this was just the proof on where the formula came from. This is the formula now that we can use for all sequences. Now let's see if this makes sense. Let's do an example here together. We're almost through today's lesson. So if I wanted to find the general term, that's what the t at n is. Here, the general term. And I know it's arithmetic. I start with a plus n minus 1 times d. So my first term in this pattern, negative 2, negative 5, minus 8, first term is negative 2. Now we're just doing this in general. We're not filling in for n. And our common difference, the common difference is negative 11, subtract the number in front of it. Here we have negative 11 plus 8, which equals negative 3. So we're decreasing by 3 in this pattern. So here, the d is negative 3. We can clean this up just to simplify it a little bit more. Our general term is equal to negative 2 plus negative 3n plus 3. I just did distributive property, and now I'm gathering like terms. So negative 3n plus 1 is our general term for this pattern. So let me just make some space here, just to really be sure that you understand this. So if I use this formula here, and I wanted to know what term 2 was equal to, it should work out to negative 5. That's term 2. So if I had negative 3 times 2 plus 1, that gives me negative 6 plus 1. So term 2 in this pattern is equal to negative 5, and that works. Okay, here's our last example, and it's just sort of an extension of what we just learned above. So now what it's asking us to do is determine the number of terms. How many terms are there in this sequence that goes from negative 3 all the way to 117? So the first thing that we want to do is get organized. Our initial term is negative 3. Our nth term, our very last term, is 117. We just don't know what term number that is yet. And then our common difference is 9 minus 5, which is equal to 4. So if we look at our formula here, we have t at n equals a plus n minus 1 times d. Let's substitute in what we know. We know the nth term is 117. Our initial term is negative 3. We don't know what n is, how many terms there are, and we know our ratio is 4. Our difference. Now we're just left with some basic algebra. Negative 3 plus 4n minus 4. 117 equals negative 7 plus 4n. Bring it over. We have 124 equals 4n.